Hello everyone, welcome back to another video. In this video, we're going to solve the question arrange buildings. Now this question is a direct extension of the previous question, which was count binary strings. So if you haven't checked that question already out, you should probably do that before jumping onto this question, as this question would require all the knowledge that we already discussed about in the previous question. Right, so count binary strings is pretty mandatory before jumping onto this question. The link to that question would be in the description box, so feel free to check it out first. Now let's discuss about the question, which is arrange buildings. I hope you already know count binary strings before this, right? So if we take our objective over here and if we read it out, it says that you are given a number n which represents the length of a road, and the road has n plots on each side. The road is to be planned such that there are no consecutive buildings on the either side of the road, and you are required to find and print the number of ways in which buildings can be built on both sides of the road. So it can be a bit overwhelming for you if you have read this for the first time. What it basically says is that we have a road, right? We have a road, and on both sides of a road we are planning to make buildings, right? We have to plan buildings. That's what we have to do, right? Now the road is of length n. This is what the first line says, right? So the size of road would be n, right? And each building is of length 1, right? So at a particular spot, you can make a building, and then you can either make a building or leave a space. So if you leave a space, the space is also of size 1. And then you can again make a building. The condition in this question is that you cannot have two consecutive buildings, right? You cannot have two consecutive buildings. You have to plan the road such that you have to plan buildings in both the sides of the road. So you would have buildings over here too. Then you can have some space, and you can have another building, then some space again. You can have another space with a space, right? That's allowed. So there could be space with a space, that's allowed. But a building with a building is not allowed, right? So something like this won't be allowed, but this is allowed, right? Of course, consecutive buildings and spaces is of course allowed, right? Just two consecutive buildings is something that's not allowed, and you have to give the number of ways in which you can plan the entire road, the number of ways in which you can arrange the buildings and the spaces such that two buildings are not consecutive to each other. That is what the question says, right? Try relating this question with the previous question, which was count binary strings, in which we had to give the number of possible binary strings of length n such that there were no consecutive zeros. In previous question, consecutive zeros were not allowed, and in this question, consecutive buildings are not allowed, right? I hope this gives you some hint. Please check that video out first, the video for count binary strings, if you haven't already. It's a direct mandatory question, right? So try this out, try this question out after you know the solution to count binary strings. It would be way easier. Then let's move on to the solution, right? So we know that we cannot have consecutive buildings, right? And we have to give the total number of arrangements that are possible such that we have to plan both sides of the road. What I'm going to do is I'm going to divide the question into two parts, right? I would say that I can have planning of one side of the road and on the side of the road, right? So I would only talk about planning the one side, a single side, right? So if we forget about the second part for now, that is the second side of the road, what we need to do is for length n, we have to arrange buildings and spaces such that there are no consecutive buildings, right? So there could be building space, building space, space, building, space, space, building, and space, building, space, building, and so on and so forth, right? For n times, as the length or the width of a building in a space is 1, right? So if we associate this with the previous question directly, what we want is, when we have, let's suppose I have 3 as my input, right? So if my road is of 3 length, right, I can have either a building or a space, right? So if I have a building, now my length of the road that I have to fill is 2. If I have space, then it's 2. After a building, I can only have a space, try relating this again. Try relating this with count binary strings. After a building, I can only have a space. So I would have building space and length is 1. But after a space, I can have a building and a space both. So I can have SB of 1 and SS of 1, right? Again, my last space, my last chunk of land is acquired by a space. So I can have building as well as space over here. So I can have BSB for 0, BSS for 0. Over here, as we had a building, I can only have a space now. So ISBS for 0. Over here, we had a space acquiring the land. So we can have either space or a building. So building or space, SSB for 0 and SSS for 0. So if we count, there are a total of 5 configurations on one side for n equivalent to 3. If we recall, for n equal to 3, the number of binary strings that were possible with no consecutive zeros was also 5, right? The answer is 5, right? This is just for one side, right? Now this is just for one side. What would I do if I had to talk about total number of arrangements that are possible such that I have to plan both sides of the road? Then if we think about it, if we use our PNC logic, permutation and combination logic, for each and every arrangement of this side, I can have an arrangement on this side. So if I have n arrangements over here, it's not taken, let's take x, right? So if I have x arrangements over here, right, for each and every arrangement of those x arrangements, I can have x arrangements over here, right? So for each arrangement under this part, I can have x arrangements over here. So for x1, if x goes from 1, if some I goes from 1 to x, then for each and every position arrangement of x, I can have x as an arrangement, right? This means that the total number of arrangements is x into x, which is x square, right? For every possible configuration on one side, can have another possible configuration on another side. So this would give me a total of n square, x square arrangements, right? So what I have to do is I have to just solve for one side. I would get my x and I just have to square that number to get my answer, right? And we already saw how we can solve for one side. For solving one side, we just have to use the logic which we used in the previous question, that was count binary strings. Instead of strings without consecutive zeros, we have to arrange building in spaces with without consecutive buildings, right? So if we directly jump on to DP now, we have seen the recursion would be the same. So if we talk about DP now, first thing, assigning the storage and meaning. So what would be storage? Storage would be similar to previous question. Now, if you remember, in previous question, we had arrays of DP and 0 and 1 at first, and then we brought that down to 2 variables because we only needed previous state. Now, in this question also, as it is possibly, you can say that the same exact question with the same exact recursive tree forming, we only think about the previous state, right? Over here, if you see, we only think about the previous state. If the previous state was space, we can have both building and space over here. If the previous state was a building, we can only have a space over here, right? So in this case also, we can only work, we can possibly only work with just 2 single variables that can hold account for previous state, right? Let's suppose those 2 variables are ending at building. So the configuration that I have up till now for a road of any length x, it can end with a building or it can end at a space, right? For ending at building, right, formula would be new ending at building would be equivalent to new ending at space, right? So if we look at the recursive tree again, over here, if we see, if I had to add a building, then I can only add a building when I had a space. Right? So for every configuration that ends with a space, I can just add a building to it, right? Just like previous question. And similarly, Similarly, my new ending at space, the current state that I'm talking about, would be equivalent to ending at space plus ending at building. This is because I can have a space after both a space and a building, right? I can have a space after a building, I can have a space after a space, but I can only have a building after a space. So this versus this, right? This accounts for this formula, this accounts for this formula. I hope it's clear. So the storage and meaning, the direction, and the traversing and solving part is exact similar to count binary strings, which was the previous question. I recommend again that you check that out first. This is the formula that we would be working with. Now again, if we talk about the base cases, if the length of road is 1, possible configuration that I would have is either have a building over here or a space, right? So for building, ending at building would be 1, ending at space would be 1. So for my n equal to 1, I would have base cases at ending at building equivalent to 1 and ending at space equivalent to 1, right? And this is only for a single side. So after the while loop, after the for loop is over, after we are done calculating for the current state, which is equivalent to n, for a single side of road, the total number of configuration would be EAB plus EAS. And then what we have to do is we have to just square this number to get our answer, because we have to provide the configuration of both sides of the road, which is discussed over here, right? Seems pretty simple and exactly same as the previous question. So let's jump on to the code editor and code this, right? So over here, what we have is a number n as input, right? So I would have a scanner object. So let's write that scanner SC is equal to new scanner system dot in, right? Then n as input SC dot next int, right? Now we have to write our base cases. Base cases when n was equivalent to 1, right? So when is n equivalent to 1, we have end at space equal to 1, we have end at building equal to 1, right? Now we would traverse and solve for lengths n equivalent to 2 to n, right? I equal to 2 to n, right? Any number. So we have int I equivalent to 2 and I goes till n I plus plus. At every state, what I have to do, I have to create a new ending at building, right, which will be equivalent to my ending at space, right? I can only add a building after a space, and my new ending at space, which is equal to ending at building plus ending at space, right? After assigning values to the new state, I have to put those states to the previous state. So EAS would be equal to new ending at state, and ending at building, which is EAB, would be equal to new ending at building, right? Up till now, the code looks exactly the same as the previous one. Again, what we have to do is we have to calculate total configurations. So that would be ending at space plus ending at building, right? This question was pretty clearly discussed in the previous video, which was count binary strings. I would again request you to watch that video before jumping onto this question. If you don't understand what this code means, please look at the previous video, right? So we have the total configurations for a single side of the road. What would be the total configurations for both the sides of the road, right? So what we want to do at this point is convert this into log, right? Because we want to square the total number, and that can possibly go out of the bounds of integer value. So I would convert it into total, and what I'm going to do is I can just have system.out.println, and as I have to square, I can do total into total over here, right? And if I run this, we are getting an error. That is because it is new ending at building, right? So if I run this again, So it is working, right? We are getting the correct output for our sample test case. If we submit this, then it's passing all the test cases. So if we come over here again on the sample, on the code that we have written, over here we have what? We have the configuration of one side of the road, right? And before printing our output, what we are doing is we are squaring that configuration. We are squaring one side of the configuration to get configuration of both the sides. So what we are doing is we are getting configuration of both the sides, right? I hope you understand the code. The last thing that we want to do is discuss the time complexity. So again, what we did was we just had a single for loop running from 2 to n. That means the time complexity would be O of n. So this would be my time complexity. And if we talk about the space complexity, again, we only use 2 variables extra. So we would have a constant space complexity, right? I hope it's clear. And I hope you liked the video. Please like the video if you did, and share the video with your friends. I will see you in the next video where we will discuss another problem on strings. Okay, see you.